Hello, my friend. Welcome in this recording. My name is Emmanuel, and on this channel I talk about programmation, usually in C++ and Python, but I can sometimes talk about different topics. It depends on what I am currently interested in, actually. Yeah. Also, I was actually trying to do some things differently now with the webcam, but yeah, I think this webcam is actually crappy. It doesn't really work very well. Yeah, I think you've seen that probably. It's the image itself is flickering, so I need to find myself a new webcam. Actually, I don't want to find a new webcam. I would like to be able to connect my camera. I have a Fujifilm X-T4 and I would like to be able to use that as a webcam on the computer, but yeah, I need a cable to connect the camera. But soon this will be ready, so we can try again and hope to have a better image. Anyway, this recording here is going to be about our devlog number 24. Nervland devlog number 24. This is a continuation of what we did previously in the devlog number 23, obviously. And in this previous one, we actually provide the initial implementation for the support of the text rendering in Nervland, which is kind of becoming an engine built with WebGPU. So in this first part, we provided everything we needed to be able to load the font texture, display the text, some kind of text slot at least. Yeah, we did some experiment on figuring out what with a bounding box and so on. I introduced support for indirect rendering also at this point. And we at the end were able to dynamically update the text, so that was good, and also position the text on the screen properly. Yes, I remember that, and added support also for the anchor, I don't know, anchor point, so you could decide to fix the text on the right or on the left or the center and so on. So this is working good. And now I'm just going to introduce a few additional small features, I guess. Starting with the text color support, because before we were just displaying the text in blue or cyan, and yeah, there was no control on the actual color. So adding support for this one was pretty straightforward. Basically, all you need is really to add a color variable in your test description structure. So let's have a look at the sources. That would be in text renderer, and we have the text description. And yes, at some point we have introduced this color. Next, what do you do with this color when you add a text? So add text, you're going to get a text description as input, and you're going to store this internally, so that the input, you actually store that in a global text slot vector. Now, before I was using separated vector of text slots per font, but I eventually figured out that it was not a good idea, because you would have an issue then to index those text slots easily. Whereas if you have a single vector of text slot, you can index them from 0 to the number of text slots that you have, which is much more convenient to do. Anyway, we're just going to store the input here in the text slot, so we're keeping track of that color. Then it's when you are about to update the data concerning your font, the font which is assigned to this text slot, obviously, that you just added. So when you do that, that way you're going to also push the color that you provided for your text on the shader side. So where do we do that? I think there's a function like update font context. This will be called whenever the font is considered to be, the font context is considered to be dirty. So you need to update data for this font. To do that, you're going to iterate on all the text slot, and you are obviously only considering the text slot that are assigned to this specific font context. Otherwise, it doesn't make sense. And you do the positioning of all your glyphs as before. And where do I have the color? It's just here. I'm going to forward the color as part of the structure data for each glyph. So this structure data for the glyph actually also change. And I think we are not providing that directly in the header file. So glyph description. So we have the source rectangle, which is the position on the font texture. We have the destination rectangle, which is a kind of still a bit messy position in the projection coordinates on screen if you want. So for instance, if you are planning to have a screen of 1920 by 1080, yeah, your destination rectangle will be using those coordinates. And then, yes, we are adding the color as an additional vector, and this one will come a bit later. So let me just get back to that. Oh yeah, what we're doing here, we are initializing the source rectangle, the destination rectangle, and the color, but not the rotation part. Because I guess the rotation part, yes, we are doing that in the second pass. This is the first pass that you do on all the you are on a given text slot, and you iterate on all the characters that you have in this text slot, and you have to do that in two passes, because the first pass is required to be able to compute what is going to be the size of your text, so the width of the text actually. And this information is needed to be able to position the text as you want, for instance, because you need to know what is the size of the text if you want to align on the right side or at the center of the text, for instance. So that's why we have one first pass and then a second pass to assign the appropriate position, and that's also where we modified the destination rectangle, and that's also where we're going to assign the rotation, which I'm not mentioning yet because rotation is another part of what we need to introduce here. So back to the post itself. What did I do? Yes, I think at some point I was not really using a text description first when I was doing this add text. I had a text input structure, and this was because I wanted to put the font in the text input but not really in the text description, so I was using two separated structures. Then I went to this implementation at some point when I realized that the input was basically the same thing as text description, except that we didn't have the font in the text description. So we could just as well provide those two arguments like that separated. And actually, most of the time, for the moment, when I call add text, I'm always using a null pointer for the font. So yeah, this argument, I'm not even really using it yet. But after that, when I decided to move the text vector outside of the font context and use a single global text slot vector, we actually needed some kind of key to relate the text slot to the corresponding font context, and the most appropriate key was obviously the font itself. So I put this font pointer back into the text description structure. So yeah, updated again the add function, add text function, and we have the font context with the font. And as I said, in the text description, you also have the font itself. And if you provide a null pointer on the text slot creation, we're going to use a default font from the engine itself anyway, so it's never going to be a null pointer at the end. So, okay, what can you do with that then? And you can create your text renderer and add a text, and when you add your text you can specify the color that you want, and this was working just fine. The next point I wanted to cover then was on the possibility to update actually any kind of settings in those text slots, because so far when you were adding a text like that, you could only update then the text value itself. So we had this set text function, and when you call this, it's going to update the text value in your text slot and mark the corresponding font context as dirty, so that in the next frame, in the next cycle, when you reach the update buffer function, this font context will be found to be dirty and it will be updated again. So we could only update the text this way. So what I've done was to introduce similar function to be able to update the position, the size, the entry point, the color, and the rotation angle. So yeah, I mean, actually then I have updated the example here. So we were already updating the text dynamically with this frame back, and the number of frame indicated as a changing value. And then I was trying to update the position, except that here, yeah, I did another try with an angle value, but you can just use a position here, and I could do MVP to build that. We'll come back to it. And yes, so with this, it's actually what we're doing here, the example that I've shown. So you update the position dynamically, and if you look at this position, so that's for the text slot number 0. The position that you want to use is for the X coordinate. You stay on the middle of the projection full size. Wait a minute. Yes, it's 1920, right? I think that's the default value for them. Let me check that. Yes, 1920. And then for the Y position, you will start at the center again, so that's the default position, but you also add an offset, and this offset is changing progressively between +50 and -50 due to this cosinus computation here. And that's what you have on this small animation then. And in fact, I guess I could just rerun that GPU. Very interesting. Yes, that's because I actually changed the size of the projection now. So here it's using those big numbers, but for the projection that I'm setting up here, I'm using a smaller projection size, which is actually matching the default size of the window that I'm building. Why did I do that? Because later on when I was trying the rotation update here with a change of the rotation angle, if your actual window size doesn't match the projection size, I mean, if the aspect ratio of your window doesn't match the aspect ratio of your projection, then you get a distortion of your text when it's rotating, because you're progressively moving from the x-axis to the y-axis, and your projection y-axis value with respect to the x size doesn't match your window aspect ratio, as I said before. So yes, I wanted to ensure that it was working fine when you were using exactly the same value. So yeah, I did this change, but now obviously we are out of the window. Let's not rebuild that anyway. What's next? Next, we introduce the support for the usage of the projection matrix itself, because before, in fact, I was still using an hard-coded value for the projection, so I was converting that into clip coordinates manually, and I didn't really know why it was not working, but that was a usual thing with me. I'm always, when I'm building projection matrix, I'm always mixing something with the near and far plane. And in this case, for instance, I was using the same value for both of them. Not good. And yeah, I just had to fix that, and then I could get something to display, except it was upside down. But that's simply because the convention in WebGPU, when it comes to up and down on the y-axis, is not quite what I was planning, I guess. I mean, with the implementation that I had for the projection. So basically, I need to flip both of them and use the top instead of the bottom when I'm building the actual projection matrix. So this is what I'm doing. Where do I do that? I think it's should be at the very beginning of the text renderer when you get the create info. In those create info, yes, you check if you want to use a projection, the auto projection matrix. And to be honest, currently that's the only option I really have. I'm not really supporting anything else. And when I do that, I do construct an auto matrix, and this one you see is expecting left, right, then top, and then bottom. But what I do is I use left, right, and then bottom, and after that top. So I'm flipping both of them. And yeah, this did the trick. So not much more to add on this one. Next thing I had to handle was kind of optimization consideration, I guess. I was until now using different number of instances. So basically, I was trying just to draw 6 vertices per character in a given text. So the first idea I got was to define a draw call where I had 6 vertices, and the number of instances would be the number of characters that I want to display. Then in the shader code, actually this is what we have here, you would use the instance ID to figure out what is the current character that you are drawing. And then you use your vertex ID, which is going to be only from 0 to 6. from 0 to 5 actually, and you use that to figure out what is the given point you are drawing in the quad that you have for your character. So this is working fine, but I've found a few articles mentioning that using instances is usually more expensive anyway than just using a vertex buffer with a single instance when you have to draw something. I'm not quite sure if this really apply here, but I thought, okay, why keep using instances anyway, while you could also do the same thing in this case without instances. The idea in this case is simply to say that you want to draw a number of vertices, which is 6 times the number of characters that you have, and you want a single instance of that. And then all you need to do once this is changed, so this is changed here in fact. So we set the instance count to be 1 now, and the number of vertices is the number of characters that we get outside of the update here, multiplied by 6. And yeah, if this number is different from what we had before, then we consider that there was an update, and we update this vertex count. So once you've done that, your vertex ID now will not stop at 6. It would go higher because you're providing more vertices. But all you need to do anyway is to divide this number of vertices, this vertex ID in this case, you divide that by 6. So this is making you nice packets of 6 vertices each time, and this division will simply give you the character index, which was the same thing as the instance index you were using previously. So this is what I did here. So once you have this character index, you can do the same thing as before, and you use the character index instead. So no big deal, working as previously without instances. And finally, yes, I just tried to add support for text rotation. As I tried to mention here, it's I don't think this is going to be very useful on the long run, but yeah, it was just more like I was thinking about it. I decided that yeah, I could give it a try anyway. So what I've done was to simply update the shader to also perform this rotation manually currently, in fact. So once you have computed the position of your point in the projection coordinates, you can actually, you have another vector now in the glyph data that I'm providing as input. So this glyph desk, after the color, we added a rotation vector, which is also a vec4, and we use the x and y coordinate in this vec4 as the center of the rotation, the position of the center for the rotation that we want to perform, and the w coordinate in this vector is the angle for the rotation in degrees, I believe. Yes, I think it's degrees because I'm using radian then. In using this position for your rotation, you can manually perform the rotation of the text, and after that you just send that to the projection transformation again. So technically that's not really the appropriate way to do it. I guess you probably want to provide a model transformation matrix to control the position, rotation, and even the scale. But yeah, this is still pretty experimental, so I thought it was an easy try to do it this way. And yes, this is it, and it was working just fine. And as I said, that's when I decided to change the projection size to fit the window, because otherwise I was distorting the text when you do the rotation. guess it's not really worth it to, yeah, recompile and demonstrate the rotation, but you can just believe me on that. If we update the angle dynamically, you will see the text rotating around and the value is updating progressively. So it's working just fine. There would be, in fact, additional stuff. I think I mentioned that somewhere. Let me find that. Yeah, I was thinking about additional future step that I could take on this text rendering system. First, for instance, currently I'm using a storage buffer to keep the data for all the characters. So for each character, we have this glyph description data. So this structure, we have one such structure per character, which is sent in the storage buffer. I was thinking maybe, I say really maybe, I'm not sure about that, it would be worth considering using a vertex buffer instead of a storage buffer. So it means that the vertex shader would receive as input exactly the data that you need to provide for this specific vertex. Which actually means duplicating a bit the data that we have for the character, because currently for each character we store the vec4 only once. But if you were to provide this per vertex, you would have to multiply the number of elements by 6. So yeah, I mean, you would have a bigger vertex buffer, but also at the same time, I think vertex buffer access is faster than storage buffer access, because storage buffer gives you the flexibility of accessing the data in a random way, so random memory access basically. Whereas with a vertex buffer, you don't have this flexibility. You just read the data one after another, and each vertex shader execution will get the data directly. So I need to check what kind of cost you have for the memory access with a storage buffer. For simple text rendering, it's probably not making any kind of difference. But still, I'm curious and I would check that eventually. Then I was thinking also about introducing some. You can actually introduce so many different effects now with a text rendering system like that. I was thinking, for instance, about a skew effect where you would distort a bit the quad for the destination quad for the rendering, so you could move a little bit the vertices on the top on the left, and on the bottom on the right, so that would distort a bit your character, so produce some kind of italic display for your font, or maybe not really. And you could of course animate such thing. This is an idea. I'm probably not going to implement it, but why not? And another thing I definitely want to keep in mind is the capability to display some kind of background box behind a text slot. That would be pretty handy, I think, because with this you can actually make some kind of button. So you could imagine either to draw a normal rectangle behind the text. Once you have the text height and width dimension, that should be fairly easy. You could apply some padding on the left, right, top, and bottom, for instance, and you could even display a border around this rectangle, and you could also use the shader to round the corner of this rectangle, so you get a round rectangle button. So these are a few ideas that I will probably come back to one day, but for now I think this is good enough for the text implementation, and I'm going to move to something else for the moment, and not quite sure what exactly, but something different for now. Anyway, so 30 minutes already, so let's stop here. Thank you very much for watching. Happy coding as usual, and see you next time. Bye bye.